Hi everyone, I'm Vanij. I teach IBDP at Nadi, and today we are going to start with logs. Now, logs is part of syllabus for both AA, SL, and HL. So we'll just go through the basics. Okay, before we start with logs, let's say I've got 2 raised to x as 4, and I want to find the value of x. I know that 4 can be written as 2 raised to 2. So if I've got 2 raised to x as 2, I can say x is equal to 2. So I got my value of x in this case. But now let's say I've got 2 raised to x as 3. Now, if 2 raised to x is 3, I can't write 3 as 2 raised to anything. So in this case, I introduce logs, and the value for this is given by log 3 to the base 2. So if I substitute my x as log 3 to the base 2 over here, I'll get 2 raised to log 3 to the base 2 as 3. So in general, let's say I've got a raised to x is equal to b. I can write x as log b to the base a, and this is read as log of b to the base a. So the base of a raised to x becomes the new base over here. My power becomes my subject, and my b, which was my answer, becomes my number inside the log term over here. Now there are some rules with logs. So before that, let's say I've got log a, and in the question, let's say they haven't given us any base. In this case, we assume the base to be 10. So this is just log a base 10. Even if they give us lga, this can be written as log a to the base 10. And if I have lna, this can be written as log a to the base e, where e is called Euler's number, and it's 2.71 something something. Now, these are just fancy ways of writing logs. So, if my base is 10, in a short way, it can be written as LGA. And if it's log A base E or log B base E, whatever, that becomes LNA or LNB. Now, before that, let's see. Let's get it up there. Okay, now let's say I've got log A to the base C plus log B to the base C. This can be written as log AB to the base C. So in general, let's say I've got log 2 to the base C plus log 3 to the base C. This becomes log 6 to the base C. Okay. Now before doing this, make sure that the coefficients of both the LG terms is 1. Like if this is 2 and this is 3, you can't multiply the terms inside the log term. Then even if it's, let's say, LGA and LGB, or LNA and LNB, let's say it's LNA plus LNB, the rule remains the same. It becomes ln of AB. Okay. Now, let's say I've got LGA or log A base C minus log B base C. Now, this can be written as log of A upon B base C. Same thing for ln. If it's ln A minus ln B, it becomes ln of A upon B. So let's say I've got log A or log 4 base 10 minus log 3 base 10. This becomes log of 4 upon 3 base 10. Okay. So this is my fifth rule. And then let's say I've got log of a raised to b base c. This can be written as b times log a base c. So my power of a comes in front of the log term. And even if I've got, let's say, a number over here, I can take it to the power over here and then write it as log a to the power b. So in general, if I've got log a base 10, and let's say in the question they've said write the answer as log 2 to the base 10, like in terms of log 2 to the base 10, I can write 8 as 2 cube. So this becomes log 2 to cube base 10, which becomes 3 raised to log 2 base 10. Okay. So doesn't matter even if it's ln. Let's say I've got ln b. This just becomes b ln a. After this, let's say I've got log a base a. Now this will always be equal to 1. To check, I can convert this to exponents. If I want to write it in the exponent form, I know this base will become my base and 1 will become my power over here, which should be equal to this a. And I know a raised to 1 will always be a. Therefore, if I got any number and my base is the same, then this always becomes 1. So if I got ln e, that will just be 1 as well. Then after this, if I got log of 1 to any base, this is always equal to 0. Again, same thing. If I write this as a raised to 0, it becomes 1, which I know is always true. So no matter what my base is, if my number over here is 1, this is always equal to 0. And then the same thing, ln a or ln1 or lg1 will also be equal to 0. Then this is an important rule. It's called change of base. Let's say I've got log a to the base b. Now I can write log a to the base b as log a upon log b and then write any base c that I want. So let's say they've given us log 3 base 2 and in the question they've said write the answer in terms of base 10. I'll write this as log 3 upon log 2 and then since they want the answer as base 10, I'll write 10 over here. Okay, so the number comes in the numerator, my base becomes the number in the denominator, and then I can choose any base that I want. Now using this rule only, let's say I write log a bit to the base b as log a upon log b, and then I take my base as a. As we have seen above, we know that log a base a is always equal to 1. So if this number over here becomes 1, won't I be left with 1 upon log b base a? So if I've got log a base b, this can be written as 1 upon log b to the base a. This is an important tool and we'll be using this a lot in questions. Yeah. Now the next rule, let's say I've got log of a number that's negative or 0. Now this does not exist. The number inside the log term should always be positive. It can never be negative or 0. Even my base can never be negative, 0 or 1. So if in the question like you get an answer, let's say log they've given you log x somehow and you found the value of x as 3 minus 3. I know log of minus 3 does not exist. So I'll just say for this there's no solution. And then the last tool, let's say I've got a raised to log b base a. Now a raised to log b base a can be written as b. So let's say I've got 2 raised to log 10 base 2. This will be equal to 10 because my base over here and base over here are the same. I get b. Base and base are the same. I get 10. Even if let's say they've given us 3 raised to 2 log 2 base 3 and they want us to find the answer for this. First, I'll take this 2 in the power. So that gives me 3 raised to log 4 base 3, which becomes 4. Okay. So that's logs and exponents.